Hello, and welcome to tonight's Space Sleep Story. If you appreciate what we do here, please like or subscribe for future relaxing nighttime space journeys. Tonight, we chronicle BepiColombo, Europe and Japan's most ambitious planetary mission. A 7-year journey to Mercury, 9 planetary flybys, dual spacecraft working in tandem. So settle into your most comfortable position, close your eyes, and prepare to witness international cooperation conquering the solar system's most extreme environment. Before we begin, let us prepare your body and mind with gentle breathing. Take a slow, deep breath with me now. Inhale gently for 4 counts. Hold the peace. Exhale for 6. Feel your body releasing into stillness. Each breath carries you deeper into relaxation. Your muscles soften, your thoughts quiet. Tonight we have time to explore together. There is nowhere else you need to be. Another gentle breath as we continue our preparation. This time, notice how your chest rises and falls, natural and effortless. Your breathing becomes slower, deeper. Let my voice be your guide through tonight's journey. Feel the stress of the day leaving your body. Each exhale releases a little more tension. With each breath, you sink deeper into your bed, becoming heavier, more relaxed. We begin now. Our story begins in Padua, Italy, 1965. A university office where mathematician Giuseppe Colombo studies radar data from Arecibo Observatory. For 76 years, astronomers believed Mercury was tidally locked, always showing the same face to the Sun. But new radar reveals rotation every 58.6 days. Colombo calculates, realizes stunning truth. Exactly 3:2 ratio with Mercury's 88-day orbit. Not locked, but resonant. 3 rotations per 2 orbits. This discovery transformed Mercury from astronomical footnote to dynamically fascinating world. Colombo would contribute even more to Mercury exploration. In 1970, NASA planned Mariner 10 mission, but lacked sufficient rocket capability to reach Mercury. Colombo walked to blackboard, drew orbital ellipses, announced quietly, "If you launch here and fly by Venus here, you reach Mercury." Engineers had spent months on trajectory analysis. He solved it in 5 minutes. Gravity assist made modern planetary exploration possible. The Mariner 10 mission flew in 1974, using Colombo's calculated Venus gravity assist trajectory. 3 Mercury flybys photographed 45% of the planet's cratered surface. Colombo made another prediction. The spacecraft's post-flyby orbit would return to Mercury every 2 spacecraft orbits, exactly 1 Mercury year. Resonant orbital mechanics validated with unprecedented precision. Giuseppe Colombo died May 20, 1984, in Padua. He never saw the full Mercury exploration his work enabled, but his legacy would endure. Decades passed after Mariner 10. Messenger became the second mission, orbiting Mercury from 2011 to 2015. 4 years of observations revealed mysteries. Why does a planet barely larger than Earth's moon possess an active magnetic field? How did such an enormous iron core form, 75% of the planet's radius? What creates the bright hollows across ancient surfaces? Where did water ice in permanently shadowed polar craters originate? More questions emerged than answers. Mercury demanded a more ambitious investigation. Around the year 2000, the European Space Agency identified Mercury as a cornerstone mission. Initial concept envisioned single orbiter launched 2009. But Mercury's environment presented unprecedented challenges. Surface temperatures reaching 430 degrees Celsius. Solar radiation intensity 6.7 times Earth's average. Technology required simply did not exist yet. Engineers needed years to develop ceramic heat shields, high-temperature solar panels, titanium radiators with specialized coatings. Thermal vacuum testing. Hundreds of thermal cycles. Innovation born from necessity. Meanwhile, Japan's space agency JAXA independently studied Mercury magnetosphere investigation. In 2003, ESA and JAXA approached each other with a proposal. Combine efforts into joint mission? JAXA would contribute magnetospheric orbiter nicknamed MEO, meaning waterway. ESA would provide planetary orbiter called MPO and launch vehicle. Partnership formalized November 2003. 2 agencies, 2 spacecraft, coordinated science objectives. European redundancy philosophy merged with Japanese mass efficiency. Together, they could achieve what neither could accomplish independently. The spacecraft took shape through international collaboration. 83 companies from 16 countries constructed MPO. Airbus facilities in Germany and United Kingdom assembled components. 16 Japanese companies built MEO at JAXA Sagamihara. Mercury Planetary Orbiter, mass 1,150 kilograms, dimensions 1.8 by 1.5 by 1.4 meters when stowed. Carries 11 scientific instruments studying surface composition, topography, internal structure. Mercury Magnetospheric Orbiter, mass 280 kilograms, octagonal prism 1.8 meters diameter. Carries 5 instrument suites studying magnetic field and magnetosphere. The thermal engineering problem alone redefined spacecraft design. MPO instruments must operate near room temperature, while surfaces facing Mercury reach 350 degrees Celsius. All within spacecraft barely 2 meters across. Solution required 50 layers of aluminized Kapton insulation, 15 centimeters thick. Titanium radiators positioned perpendicular to both Sun and Mercury, radiating waste heat to deep space. Ceramic tiles protecting critical components using same material technology as Space Shuttle. Multiple thermal zones actively managed. Innovation on every level. Solar electric propulsion presented different challenge. Ion thrusters must operate 15,000 hours continuously, unprecedented duration. Kinetic T6 thrusters ionize xenon propellant, accelerate ions to 50,000 meters per second exhaust velocity. Produce just 0.29 newtons thrust combined, barely enough to hold a smartphone. But running continuously for years, consuming only 230 kilograms xenon, they provide over 7 kilometers per second velocity change. Chemical rockets could never accomplish this. Low thrust, but extraordinary efficiency. Why does reaching Mercury require such complex trajectory? Counterintuitive orbital mechanics provide the answer. Reaching inner planet requires slowing down, not speeding up. Must shed Earth's 30 kilometers per second orbital velocity while falling deeper into Sun's gravity well. Chemical rockets lack sufficient fuel capacity. Solution involves 7-year cruise with 9 planetary flybys, 1 Earth encounter, 2 Venus encounters, 6 Mercury encounters. Each flyby provides gravitational braking, gradually reducing velocity to match Mercury's orbit. Patient, precise, carefully orchestrated. The complete spacecraft stack grew massive. Mercury transfer module at bottom, 1,400 kilograms including fuel, equipped with 4 ion thrusters. Mercury magnetospheric orbiter sunshield, 15 meters diameter, protecting entire stack during approach. MPO with 11 instruments mounted above, MEO attached on top. Total mission mass at launch, 4,080 kilograms, including 745 kilograms hydrazine and 580 kilograms xenon propellant. One of heaviest scientific payloads sent to inner solar system. Comparable to Cassini's mass, but facing more extreme thermal environment. October 20th, 2018 approached. Kourou, French Guiana. Launch complex preparations complete. Ariane 5 rocket stands ready, 320 tons, fueled and prepared. 01:45:28 UTC. Engines ignite. Brilliant exhaust illuminates tropical night. Earth trembles as rocket climbs, accelerating through atmosphere, arcing towards space. 2 upper stage burns achieve low Earth parking orbit, then inject BepiColombo onto interplanetary trajectory. Spacecraft separates 26 minutes after launch at 8,700 kilometers altitude. 7-year journey begins. Early operations revealed challenges. Medium gain antenna deployment incomplete, limiting data transmission rates. Star tracker interference from scattered sunlight required software updates. Mission teams troubleshoot remotely from ESA Operations Center in Darmstadt, Germany, and JAXA control in Sagamihara, Japan. 8-hour time zone difference demands coordination. Uploading patches, testing solutions, validating fixes. By June 2019, issues resolved. Spacecraft operating nominally. Ion thrusters ignite, beginning years of continuous low-thrust propulsion. The gravitational ballet begins April 10th, 2020. Earth flyby at 12,677 kilometers altitude. Velocity changes by 3.6 kilometers per second through gravitational interaction. Instruments photograph home planet for calibration. Familiar blue marble growing distant. October 15th, 2020, brings first Venus encounter at 10,720 kilometers altitude. Velocity reduces 1.4 kilometers per second. August 10th, 2021, second Venus flyby skims just 552 kilometers above surface. Closest approach to any planet, entire mission. October 1st, 2021, marks historic moment. First Mercury encounter. Spacecraft passes 200 kilometers above nightside. Cameras activate, photographing cratered terrain. Magnetometers measure field structure. Gravity breaks velocity by 0.7 kilometers per second. 5 more Mercury flybys follow over next 4 years. June 2022, June 2023, September 2024, December 2024, January 2025. Each reducing velocity incrementally. Each providing brief scientific observations. Each fine-tuning trajectory for final orbit insertion. Between flybys, ion thrusters fire continuously. Xenon ions accelerate, exhaust plume glowing faintly blue in solar glare. Spacecraft maintains constant orientation, 15-meter sun shield facing sun, protecting spacecraft behind. Solar panels generate power despite intense radiation. Trajectory gradually spirals inward, toward Mercury's orbit. Engineers accumulate 15,000 ion thruster operating hours, equivalent to running car engine continuously for 1.5 million kilometers. Propellant consumption, 230 kilograms xenon over 7 years. Remarkable efficiency. Mission control operations face unique challenges. ESA-JAXA in Darmstadt, Germany, and JAXA ESAS in Sagamihara, Japan, coordinate across 8-hour time zone difference. When European teams sleep, Japanese teams monitor spacecraft. Critical maneuvers require both teams awake. Communication delays complicate everything. At maximum distance, radio signals take 13 minutes to reach spacecraft. If problem occurs, spacecraft must diagnose and respond autonomously before ground controllers know issue exists. Engineers design systems trusting spacecraft judgment. Onboard fault protection with authority to safeguard mission. COVID-19 pandemic forced adaptations in 2020. Earth flyby happened during lockdown. Mission-critical maneuver executed with 3 people in control room instead of usual 15. Families couldn't visit, couldn't celebrate together afterward. But spacecraft didn't care about pandemic on Earth. It demanded same precision regardless of human difficulties. Teams delivered flawlessly despite circumstances. Space exploration continues through Earth's challenges. Persistence overcomes obstacles. Planetary flybys provided unexpected science. Venus encounters detected phosphine signature in atmosphere, sparking scientific controversy. Biological processes? Geological sources? Measurement error? Debates continue across scientific community. Mercury flyby, magnetosphere measurements revealed dynamic, complex field structure changing between encounters. Temporal variation or solar wind influence? Questions accumulate awaiting orbital phase observations. Each flyby photographs surface at oblique angles with unusual lighting. Mysterious bright hollows appear more extensive than messenger revealed. December 5th, 2025 approaches. 7 years, 1 month, 15 days after launch. BepiColombo nears Mercury for final time. Not flyby now, but capture. Main engine ignites burning hydrazine, producing 1,050 newtons thrust. Velocity decreases by 2.3 kilometers per second over 18-minute burn. Gravity captures spacecraft into 590 by 11,640 kilometer elliptical polar orbit. 7 years preparation culminate in single critical maneuver. Success achieved. Mercury transfer module separates. Propulsion stage that guided spacecraft for 7 years. Fuel depleted. Mission complete. Entering independent solar orbit. MOSIF sun shield that protected spacecraft entire journey separates as well. Both drift away from Mercury into deep space. Remaining stack consists of MPO with MEO still attached, preparing for next phase. MPO performs series of additional burns over following weeks, lowering and circularizing orbit progressively. Final configuration achieved, 480 by 1,500 kilometer elliptical polar orbit. Orbital period, 2.3 hours. March 2nd, 2026, marks Separation Day. Spring-loaded mechanism releases MEO from MPO after 7-year journey together. MEO's apogee motor fires, raising apoapsis to 11,640 kilometers. 9.3-hour orbital period established. 2 spacecraft now independent, each in specialized orbit optimized for unique science objectives. MPO orbits low, studying surface and interior. MEO orbits high, sampling magnetosphere. Every 4 MPO orbits, MEO completes 1 orbit. Regular alignments provide coordinated multi-point observations. April 2026. Primary science operations begin. MPO cameras photograph surface building, high-resolution global map at 5-meter resolution. Smaller than tennis court, far exceeding messenger capability. Mertis infrared spectrometer identifies minerals, measures temperatures, detects volatile compounds in permanently shadowed craters. Mix's X-ray spectrometer measures characteristic fluorescence revealing elemental composition. Magnesium, aluminum, silicon, sulfur, calcium, iron mapped globally. Bella laser altimeter creates topographic model with 1-meter vertical precision. MEO's instruments sample magnetosphere from high apoapsis. Magnetometers measure fields with 0.1 nanotesla sensitivity. Plasma particle detectors cover 10 electron volts to 30 kiloelectron volts energy range. Solar-wind interactions studied in unprecedented detail. How does Mercury's weak magnetic field, just 1% Earth's strength, interact with intense solar wind? Why does small planet retain active dynamo field billions of years after formation? Combined observations from two positions reveal answers. Temporal variations distinguished from spatial structure. Scientific expectations focus on fundamental mysteries. 1 Earth year primary mission duration equals 4 Mercury solar days. Observations will map 100% of surface at 5-meter resolution. Determine surface composition globally. Identify rock types. Detect volatiles. Create precision topographic model, revealing crustal structure, impact basin morphology, volcanic features. Characterize magnetic field source, determining core size, convection patterns, field generation mechanism. Study magnetosphere dynamics and exosphere composition. Extended mission possible if spacecraft health permits. BepiColombo represents multiple firsts in planetary exploration. Europe's first Mercury orbiter, Japan's first inner solar system mission, first dual-spacecraft Mercury investigation, most powerful solar electric propulsion system flown to date. Mission demonstrates international cooperation at unprecedented scale. 2 space agencies, 2 spacecraft, coordinated science, shared data. Combined expertise exceeding either agency's independent capability. ESA contributed €1.65 billion. JAXA approximately €250 million. Giuseppe Colombo's mathematical insight from 1960s and 70s enabled this mission. His trajectory calculations made Mariner 10 possible. His resonance discovery revealed Mercury's true nature. 60 years later, spacecraft bearing his name arrives to complete investigation he initiated. From blackboard sketch to billion-euro mission, scientific legacy spans generations. Colleagues remembered mathematician working problems entirely in his head, preferred physical intuition over formal mathematics, would announce quietly, "I have an idea," then sketch orbital trajectories freehand. University of Padua students recalled professor who made celestial mechanics accessible. One remembered Colombo saying, "Gravity is geometry. Once you see shapes orbits must follow, equations become obvious." He taught visualization first, calculation second. Beyond BepiColombo mission naming, lunar crater Colombo, designated by International Astronomical Union in 1976. Asteroid 7103 Bepi, named 1994. University established Giuseppe Colombo Prize for Celestial Mechanics Research. Legacy endures through those he inspired. Johannes Benkhoff, ESA project scientist since 2005, reflects on mission meaning. BepiColombo represents 15 years of my career, but also humanity's best attempt to understand why Mercury exists as it does. The planet defies every simple explanation. Shouldn't have magnetic field, shouldn't have ice. shouldn't have such enormous core. We're going to find out why. Go Murakami, JAXA project scientist, speaks of partnership. Building spacecraft together taught European and Japanese teams to blend engineering philosophies. Combining both made better mission than either could achieve alone. Airbus engineer Ulrich Reininghaus describes thermal challenge. We needed material withstanding 350 degrees Celsius on one side, while keeping instruments at room temperature on other. Separated by just 15 centimeters. Nothing in our catalog worked. We invented new thermal protection system specifically for Mercury environment. Kinetics Orson Sutherland reflects on ion thrusters. These engines must operate 15,000 hours, more than any previous solar electric propulsion. Our engines do this while sipping fuel so efficiently, just 230 kilograms xenon for 7-year journey. Launch campaign manager Philippe Mongrard recalls October 2018. Weather delayed us twice. Each delay costs 500,000 euros and stresses spacecraft. But you never rush launch. At T-10 seconds, watching engines ignite beneath 4 tons of spacecraft representing 20 years' work from 100 companies. That's when you realize how many people trusted you to get this right. We did. Flight director Elsa Montagnon reflects on operations. Our commands take up to 13 minutes to reach spacecraft. Spacecraft must diagnose and respond autonomously. JAXA's Yoshifumi Saito describes June 2022 Mercury flyby. We had 30 minutes closest to Mercury. 15 instruments between both spacecraft collecting data simultaneously. Captured plasma measurements showing solar wind directly impacting surface because magnetic field is so weak. That single flyby proved what we'd theorized for decades. Mercury's magnetosphere is porous, permeable to solar wind. Andrea Akomazzo speaks of international coordination. Mission Control in Darmstadt and ISAS in Sagamihara operate 8 hours apart. Space exploration forces humanity to collaborate. Spacecraft operations engineer Christoph Stangl remembers pandemic operations. Earth flyby happened during COVID lockdown, executed with 3 people instead of 15. Families couldn't visit, couldn't celebrate together. But spacecraft demanded same precision, regardless of Earth's problems. We delivered. ESA's Anne-Karine Van Daal reflects on Venus science. BepiColombo isn't Venus mission, but 2 flybys provided unique observations. Detected phosphine signature sparking controversy. Science rewards prepared minds with unexpected timing. Professor David Rothery from Open University, Symbiosis co-investigator, shares anticipation. I've studied Mercury 40 years through telescopes and messenger data. December 2025. Cameras I helped design will photograph surface at resolution showing features 5 meters across. At 65 years old, this arrival represents culmination of my scientific career. I'll see things about Mercury no human has ever observed. Dr. Valentina Galuzzi reflects as next-generation scientist. I was undergraduate when BepiColombo launched. This mission will define my generation's contribution to planetary science. As narrative slows, we reflect on what space exploration represents. BepiColombo, one mathematician with pencil and paper calculating orbits. His insights enable missions decades later. Engineers across 16 countries building spacecraft to withstand environments humans could never survive. Scientists dedicating careers to studying world most people never think about. Controllers coordinating across time zones, languages, cultures. Unified by curiosity about smallest planet in inner solar system. December 2025. 2 spacecraft orbit Mercury. Instruments measuring, cameras photographing, data streaming across 91 million kilometers to Earth. Questions accumulate about iron core formation, magnetic field persistence, water ice origins. Science doesn't answer questions immediately. It collects data, tests hypotheses, builds understanding incrementally. BepiColombo observations will fuel research for decades. PhD theses, scientific papers, refined theories. Tonight we rest, knowing humanity's emissaries orbit the solar system. BepiColombo at Mercury, missions at Venus, rovers at Mars, spacecraft exploring outer planets, probes in interstellar space. Curiosity drives exploration. Mathematics enables it. Engineering implements it. International cooperation sustains it. One mission, one planet, part of centuries-long endeavor to understand cosmos we inhabit. The spacecraft orbits silently above Mercury's ancient cratered surface. Solar panels tracking sun's movement. Instruments observing patiently, methodically. Data returns to Earth, where scientists analyze discoveries. Understanding deepens with each observation. This is how humanity explores. Patiently, collaboratively, persistently. One mission at a time. Mercury's surface stretches below, gray and ancient. Craters billions of years old. The spacecraft continues its patient watch. Polar regions hold ice in permanent shadow. Water preserved in eternal darkness. Mysteries waiting to be understood. The magnetic field pulses invisibly. Ancient dynamo still active. Planetary core generating protection. Solar wind streams past at hundreds of kilometers per second. Interacting with weak magnetosphere. Dance of plasma and magnetic fields. Instruments measure temperature extremes. 430 degrees in sunlight, negative 180 in shadow. Bright hollows scatter across ancient terrain. Sublimation creating mysterious features. Surface evolution continuing today. MPO completes another orbit every 2.3 hours. MEO's orbit takes 9.3 hours. Coordinated observations revealing secrets. Laser altimeter pulses measure topography. 1 meter vertical precision, creating detailed map of planetary surface. X-ray spectrometer detects elemental composition. Silicon, iron, magnesium, sulfur. Chemical fingerprints of ancient formation. Infrared observations map mineral distributions. Different rock types revealed by spectral signatures. Volcanic plains, impact ejecta, ancient crust. The enormous iron core dominates planetary interior. 75% of radius. Largest core fraction of any planet. Scientists analyze data arriving from spacecraft. International teams collaborating on discoveries, understanding Mercury's formation and evolution. Seven years of journey complete. Decades of planning fulfilled. Mission succeeding through human cooperation. Giuseppe Colombo's legacy lives on. Mathematical insights enabling exploration. One person's work spanning generations. Europe and Japan's partnership demonstrates possibility. Nations working together toward shared goals. Space exploration uniting humanity. The spacecraft continues its silent vigil, observing, measuring, discovering. Patience rewarded with knowledge. Mercury orbits Sun every 88 days, rotating 3 times per 2 orbits. Resonance, Colombo discovered. BepiColombo's mission reveals planetary secrets. Answering questions posed for decades, science advancing understanding. Tonight, rest peacefully. Spacecraft orbits Mercury. Mission continues. Stars surround the spacecraft. Eternal cosmic backdrop. Silent observation. Data streams to Earth. Knowledge flowing homeward. Discovery continuing. International cooperation succeeds. Humanity united in exploration. Shared achievement. Mercury's mysteries slowly revealing. Patient investigation rewarded. Understanding deepening. Seven-year journey complete. Mission beginning. Observations continuing. Rest now in peace. Spacecraft watches over Mercury. All is well. floating through space. Silent orbital motion. Peaceful existence. BepiColombo orbits. Mission continues. Sleep peacefully. Instruments observing, data collecting, knowledge growing. Mercury waits below. Ancient world, eternal patience. Spacecraft silently orbits. Endless observation. Rest now. Stars shine eternally. Peaceful cosmos. Sleep deeply. Mission succeeds. Humanity explores. Rest peacefully. Drifting in orbit. Gentle motion. Complete peace. BepiColombo watches. Silent guardian. Sleep now. Floating peacefully. Infinite calm. Rest. ancient Mercury below, rotating slowly. 3 rotations every 2 orbits. Colombo's discovery verified. Thermal protection holds spacecraft safe. 350 degrees outside. Room temperature within. Ion thrusters silent now. 15,000 hours operation complete. Mission accomplished. MPO and MEO working together. 2 spacecraft, coordinated observations, international partnership. Cameras photograph cratered surface below. 5-meter resolution imaging. Unprecedented detail. Magnetometers measure invisible fields. 0.1 nanotesla sensitivity. Precise measurements. Laser pulses measure topography. 1 meter vertical precision. Detailed mapping. X-rays reveal elemental composition. Iron, magnesium, silicon mapped. Chemical signatures. Infrared detects minerals below. Spectral analysis revealing rock types. Geological understanding. Polar ice remains protected. Permanent shadow preserves water. Ancient deposits. Bright hollows scatter across terrain. Mysterious features studied closely. Surface evolution. Core dynamo generates magnetism. 75% planetary radius. Enormous iron core. Solar wind bombards magnetosphere. Porous field allows penetration. Dynamic interaction. Temperature extremes measured continuously. 430 to -180. Harsh environment. Exosphere elements detected floating. Sodium, potassium, calcium observed. Tenuous atmosphere. Data transmits to Earth constantly. 91 million kilometers traveled. Knowledge returning. Scientists analyze discoveries daily. International teams collaborating worldwide. Shared understanding. Giuseppe Colombo, remembered always. Mathematical legacy enduring forever. Inspiration continuing. Europe and Japan partnered successfully. Cooperation achieving shared goals. Unity prevailing. Mission primary phase continuing. 1 Earth year observations. Science progressing. Extended mission possible ahead. Spacecraft health permitting continuation. Hope remains. Mercury orbits silently below. Ancient world waiting. Rest deeply. Spacecraft watches eternally. Patient guardian. Sleep peacefully. Stars shine endlessly. Cosmic beauty. Complete peace. BepiColombo continues mission. Silent observation. Rest now. Data flows homeward. Knowledge streaming. Sleep deeply. International cooperation succeeds. Humanity united. Peace prevails. Instruments measure quietly. Discovery continuing. Rest. Mercury waits below. Eternal patience. Sleep. Orbital motion gentle, floating peacefully. Rest. Mission accomplished. Success achieved. Peace. Spacecraft orbits. Silent watch. Sleep. Stars eternal. Cosmic peace. Rest. BepiColombo watches. Guardian orbiting. Sleep. Mercury below. Ancient world. Peace. Floating gently. Complete calm. Rest. Mission continues. Eternal watch. Sleep. All is well. Rest now. Peace. Sleep deeply. Good night.